everyone, welcome back to our channel, that is QPOL. My name is Anjali Mishra. Students, in this video we are going to cover the remaining questions of chapter 2, which was about acids, bases and salts. So students, हमने आपके previous video में discuss किया है till 8th question. So this video will be from question 9th to the remaining questions which are there in the exercise part of this chapter. So starting with question 9th, the question says that the question says 5 solutions which are being named as A, B, C, D and E. So let's just name them as A, B, C, D and E. When tested with an universal indicator, showed pH change as 4. 1 will have a pH value of 4. B will have a pH value of 1. C will have a pH value of 11. D will have a pH value of 7. And lastly, the solution E is going to have a pH value of 9. So students, first we have to get back into the pH scale just to remember that if we are getting a pH value of, let's just say, 2 or 4 or 11 or 12 or even 7, what does it means? So in pH scale, let's just say, students, that this is our pH scale. So basically this pH scale has got numbers such as 0 to 7 and then till 40. So this is high time that we should know that all the solutions whose pH value is like between 1 to 6.9 are acidic in nature. The one whose pH value is like between 7.1 to 14 are basic in nature. And the solutions who has got exact value of 7, these are called neutral substances. For example, distilled water. So we know that the solutions are acidic in nature or basic in nature with the help of pH scale. But the question is, how we can say that which one is strongly acidic or which one is strongly basic? Which one is weakly acidic or which one is weakly basic? So for that, आपको याद रखना होगा that if a solution is getting a value between 1, 2, 3 or 4, let's just say 4. So these are going to be strongly acidic. On the other hand, if there is a solution whose pH value is like from 4.5 till 6.9, then they'll be called weak base. Talking about the basic side, if there is a solution whose pH value is like between 9 or 10, we'll say these are weakly basic. On the other hand, if there is a solution whose pH value is like, let's just say it's between 13 to 13.5, these are said to be strongly basic. So getting back to the question, we have got 5 solutions. So out of these 5 solutions, each and every one of them have got different value in the pH scale. So starting with the first, let's just start with solution B because its pH value is 1. So we'll say that solution B is strongly acidic. But the solution A is going to be weakly acidic. Just like this, Solution E will be weakly basic, but solution C will be strongly basic. And lastly, D has a pH value of 7. So we will say that it can be distilled water. That means it's a neutral substance. Alright. So this is how we can answer question number 9. Moving on to question number 10. Students, question number 10 says that equal length of magnesium ribbon are taken in test tube A and test tube B. So we have test tube A and we have test tube B. So both of them have got magnesium in it. Now in case number 1, we will add, like, to the test tube A, we will add some amount of hydrochloric acid, that is HCl. While to test tube B, we are going to add some amount of acetic acid. So on the basis of this, the question says in which test tube will be freezing occurring more vigorously and why? So we'll answer this question by saying that HCl, as we all know, is a strong acid. Actually, it's a very strong acid. So freezing occurs because of production. Like, first statement is, if you will compare acetic acid with hydrochloric acid, we can say hydrochloric acid is a strong acid and freezing is all about production of hydrogen gas. And only strong acids are capable enough that they can release huge amount of hydrogen gas. So we'll say that HCl is a strong acid while acetic acid is a weaker acid. So freezing will occur because of production of hydrogen gas, which will happen when magnesium will react with hydrochloric acid, because here magnesium on reacting with 2HCl will release magnesium chloride and some amount of hydrogen gas. So this is proving that the test tube A will show freezing because test tube A is the place where there will be more amount of production of hydrogen gas. Moving on to the question number 11. Students, question number 11 says that question is, fresh milk has a pH of 6. What do you think the pH will change as it turns into curd, and explain your answer? So basically we can answer this question by saying that fresh milk will turn to to curd because of production or due to production of lactic acid. So lactic acid will reduce the pH of milk. Moving on to the next question, which is question number 12. The question is again based on milk. So the statement says a milkman adds a very small amount of baking soda to fresh milk. And on the basis of this, we have got two questions. Why does he shift the pH of fresh milk from 6 to slightly alkaline so that he could prevent milk from getting sour because it can lead to the production of lactic acid. So we can say it will prevent production of, basically it will prevent milk from getting sour due to production of lactic acid. This is the first answer. Second question is, why does this milk takes a long time to set as curd? So we'll answer this question by saying that this milk is going to take pretty long time to set as curd because the lactic acid here first neutralizes the pH and then the pH is reduced to turn the milk to curd. So we'll say lactic acid will first neutralize pH and then reduces it to form curd. So that is how you people can answer question number 12 as well. Moving on to the next question, which is question number 13. The question says that plaster of Paris should be stored in a moisture of container. Explain why. The answer is pretty simple. Plaster of Paris should be stored in moisture proof container because moisture can affect plaster of Paris. By slowing down the setting of plaster. That's it. Now we have our next question, that is question number 14. So students, this question says that what is a neutralization reaction and give two examples of it. So we'll answer this question by saying that the reaction of acid plus base gives a product of salt and water, which is considered as a neutralization reaction. Examples are, we have sodium hydroxide reacting with hydrochloric acid in order to form sodium chloride and water. The next reaction would be magnesium hydroxide reacting with hydrogen carbonate, that is H2CO3, forms magnesium carbonate. Again, it's a type of salt plus 2H2O. So this is how we have answered that what is a neutralization reaction, and also we have answered about two different examples of neutralization reaction. Moving on to the last question of this chapter, which is question number 15. Question says, give two examples of washing soda and baking soda. So let's write our headings as washing soda on one side and baking soda on the other side. So the first use of washing soda would be it is used as an electrolyte. Second use would be it is used as water softener for laundry. So we'll write it as water softener for laundry. Next use would be of baking soda. So it is used to test garden soil for acidity. Extremely important use of baking soda. It will be testing that whether the garden soil is acidic in nature or not, and then it is used for washing car without damaging the color of the paint on the car. So students, with this we have covered all the questions which were there in chapter 2. I hope these videos are helpful for you. Students, like in your coming videos now, along with discussing things which are there in different chapters, chapter by chapter, we will be doing a series where from every chapter we are going to discuss those questions which are most frequently asked in your exams. So with this, we'll end your video here and we'll see you in the next video. Thank you.